Okay, it's time for us to get smarter. Ding, 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 ding. Okay, so we need to talk a little more definition. We need to talk about more equation, but we need to get a little smarter at the same time. So I keep talking about mobile phase, right? I keep saying, oh, the mobile phase goes into the column, and the mobile phase will go through the stationary phase, and that makes me sound even smarter, right? And that stationary phase will retard my components, and I get these T sub R's and T sub M's as far as retention time goes. Okay, well, we've also talked about this word of separation. My components will begin to separate from each other. In the world of chromatography, they don't like to use the word separate. I don't know why. Maybe they have a power trip, and maybe they want to use something else besides the word separate to make themselves sound a little smarter. But the word that they typically use in substitution of separate is elution. E-L-U-T-I-O-N. Elution. So I'm going to start saying that my sample will elute from the column. Or the sample undergoes the process of elution in the column. And elution is just basically talking about separation, okay? The piece that comes from the bottom of the chromatography column that I'm collecting into the vial down below, this is not going to be called my component. This is not going to be called my sample. This is my separated sample, right? So if the sample undergoes the process of elution, or if my sample elutes in the column, we're actually going to call this sample that I'm collecting the eluate. E-L-U-A-T-E. The eluate. It's just another definition, another term that I can use to describe the same thing. So if you're reading this maybe journal, or if you're reading a method that's out there and they're talking about elution and elute and the eluate, this is basically what they're referring to. The sample elutes in the column and you collect the eluents out of the other side. Okay? Now, all of this has to happen due to some flow. We have to continue to put mobile phase into the machine. So flow rate is going to be very important for us. And flow rate is basically the speed that the mobile phase is traveling through the column. When I turn myself toward the instrumentation, I have control of the flow rate. If I'm doing it by hand, I'm very limited. I really allow gravity to take over and control my flow rate, and I'll just watch it drip, 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 drip out of the bottom. But if I'm using equipment, then I can go into a software or to the instrumentation settings, and I can increase or decrease the flow rate. And I can allow these things to speed up or to slow down depending on what I need for that method. The flow rate has a unit, and it's typically milliliters per minute. So milliliters of mobile phase per minute that goes through the column. That's really what we're referring to here. So mils per minute, whether that's liquid or whether that's gas, it really doesn't matter. But that's the unit that's assigned with flow rate almost every single time. And the working flow rate range is typically 1/2 to 2 mils a minute. In our laboratory, we don't really do anything most of the time over 1.5 mils a minute. The reason is because as you increase the flow rate, as the flow rate goes up, then your pressure typically goes up in the system as well. you're pumping things through faster, and that's building pressure up inside of the system little bit by little bit by little bit. And if you pump too much stuff through the system, then what happens is that your tubing and all of your connectors can start to blow. And imagine your water pipes busting at the joints. That's basically what's happening here if we turn the flow rate up too high. So because of that, most of the working labs that are out there are anywhere between 1/2 to 2 mils a minute. Anything slower, you don't really get good separation. Anything faster, well, you might not get good separation either, or the pressure is going to increase and you're basically going to blow the tubing up. And you don't want that to happen either. So that's going to be what I call the working range. 0.5 to 2 is typically the sweet spot for chromatography, but in our lab we never really go over 1.5, and in some common laboratories you probably will never go over 1.5 either. That's typically the highest that we've ever seen on a run-of-the-mill method on a typical working day in a laboratory. Okay, so that's flow rate. It can be changed based on user setting, 1/2 mil to 2 mil a minute most of the time. Okay? All right, so that's where this video is going to stop. And then in the next one, we'll pick up and we'll talk about more terminology and we'll talk about more things that are chromatography related. So come back and see me. Bye-bye.